Hello everyone, we're going to talk about hypothesis testing today, and we're going to start out with some familiar territory. So what you're going to see on the board is some stuff that you've already done. They're going to be really similar to examples that we've seen before, and then we're going to expand this a little bit. Okay. So first of all, let's talk about what a hypothesis is. A hypothesis is a testable statement. So a lot of times people think a hypothesis is an educated guess. Forget that. That has nothing to do with the way science works. So we start out with testable statements, and then we will we'll try to disprove them. We usually can't prove hypotheses in biological sciences. Okay, so here's the scenario we're going to work with. So we've talked about this sort of thing before. We have this new fertilizer and we want to know if it works. So what we're going to do is we're going to have two test plots, one of some plants that we fertilize and another of some plants that are not fertilized. Okay. So out there in outer space or somewhere in the universe, we have actual parameters for the effect that this fertilizer is having on these plants, right? But we have to work with data. So in our test plot, we're going to be putting 20 plants of each. Okay, so we have 20 that are fertilized and 20 that are not fertilized. Let's say we raise them up and we measure them. Well, the fertilized plants are a little taller, but remember there's only 20 of them, so we're not really sure. As you can see, they only differ by like 2, maybe centimeters, millimeters, doesn't really matter. We don't need to worry about units now. They don't differ by very much. Okay, for this one, we're going to say that we actually know the population standard deviation. Notice that is a parameter. And that doesn't really happen in the real world very often, as you know. We're going to find out how we deal with a situation when we have to estimate this. But just for illustration purposes, we're going to assume we know what the population standard deviation is. Okay, so the first step of hypothesis testing usually involves generating hypotheses, as you might guess. So one of the most important ones is the null hypothesis. So this is what we're actually trying to disprove. In this case, our null hypothesis would be that the fertilized plants are the same as the unfertilized plants. In other words, there's no effect. So if that's true, notice that if you subtract the unfertilized plants from the fertilized plants, that's equal to 0. Anyway, this is how a null hypothesis can be written. So it can be written in words, something like the fertilizer has no effect, or it can be written as a formula like I've done here. Okay? Then there's an alternate hypothesis. The alternate hypothesis in this experiment would be that the fertilizer is affecting growth. So in other words, fertilized plants are not the same height as unfertilized plants. Or if you subtract these two things, it is not equal to 0. All right. So in previous, first of all, you should recognize this example as a difference between means. I mean, that's what we're doing over here. We're taking a difference between means. That's what I've done over here with the data. I've taken a difference between means. Okay. Now, let's just start out assuming that this null hypothesis is the real thing out there. So we could model a sampling distribution of the null hypothesis. That's what I have here. So, the average of that should be 0, but sometimes, just by chance, we'll get slightly higher scores, and sometimes, just by chance, we get slightly lower scores. Now, this is a sampling distribution of the difference between means. So it's a sampling distribution of this relationship. Now, remember that the standard deviation of a sampling distribution is the standard error. So if we want to know about how wide this thing is, this normal distribution is, we would need to calculate the standard error, and that's what I have here. So far this should be fairly familiar territory. So now we've got this value that we got, and if this is true, if the null hypothesis is true, then this value should be somewhere in this distribution, right? Okay. You know how to do that. You know how to look at a normal distribution and ask, how likely is this score, don't you? Okay, so that's what we're going to do. So in other words, that 2 is somewhere on here. I'm just going to add it in here. And to find out how likely it is, what we're going to need is this area right there. Okay? So you know how to do that. So we can use Lane's normal calculator here. Let me just see how this looks on the screen. Okay, let's get this a little closer here for folks. Hopefully everybody can read that. I think you guys have set this up a ton of times before, right? So notice that I have the mean here of 0, okay? And I'm looking for the probability of getting 2 or higher. You see that? And then I put in the standard error there. That's what I calculated on the board. Okay, remember it's the difference between means. So let me just look back over here real quick at the standard error calculation. All right, so remember when calculating standard error, when it's the difference between two means, we use this formula where we add the variance of one divided by the sample size plus to the other one, right? So you probably recognize that formula. So that gives you, that's where I got that standard error, or the standard deviation there. Okay. So now, going back over here, when you hit recalculate, that's the probability you get. Notice how it's shaded in there. So, as you can see, that probability is pretty low, but it's not impossible. So what we have here is we have a situation where our data actually falls on the model we made of the null hypothesis, because that's what that is. That is a model of the null hypothesis, and our actual data is in there. So then you look at this probability, you're like, well, okay, it's in there, but it's not very likely. So what does that mean? Does that mean that the null hypothesis is wrong? Can we reject it? Well, that depends on how unlikely is unlikely enough. Okay, so you probably remember that usually unlikely enough is 5%. So notice in this case, it is a little above 5%. So we would not be able to reject the null hypothesis here. Okay, so how would you report this? I'm going to go back to the board now. All right. Okay, so for this particular problem we just worked, the answer would be, we were not, actually let's see, let's stick with active voice. We could not reject the null hypothesis. You like that? No, because it's got jargon in there, right? How about this? So I'm showing you some things you might not want to say. We did not find a difference between the fertilized and unfertilized plants. Okay, so that's probably the best way to say it. Now, usually if you were going to be reporting this in a scientific paper, people like to see a statistic and a probability. So far we've got a probability because we just got that over there. So let's just put the probability in here for now. Usually we put them in parentheses like this. And so we're going to have 0.056, what was the rest? 9. Okay, that's the probability. Okay, so somebody reading this will be able to look at that number and go, okay, well, they didn't find a difference, but the probability is pretty low. So maybe if they had a bigger sample size, they would have gotten a significant result. I mean, that could definitely be done at this point. So you could rerun the experiment with a larger sample size. That would give us more power, so we might actually be able to reject this null hypothesis. Okay. Now I want to elaborate a little bit more about what we do with these probability values. Okay, so I'm going to erase this. We will come back to this example in a little bit. All right? Okay. So, first of all, what we were looking at is we had modeled the null hypothesis. Right? We modeled the null hypothesis. This is almost always what you do when you work problems in this class. So we modeled the null hypothesis, and then we looked to find out where our sample statistic fell on this null hypothesis. Remember, the null hypothesis that we were modeling is a sampling distribution, okay, of the test we're working with. All right. Now, there could be an alternate hypothesis out there. Okay, so this is going to be the null hypothesis. We'll just put this up here. All right. So there could be an alternate